Welcome back. We have some announcements. Um, this is the first announcement. Finally, we have a winner for the contest one. We're about to have another contest, by the way. So this is the fastest key value store in the Midwest. That may be not true. It's the fastest key value store that was submitted to the contest in this class. Okay, page 2. So we did a bunch of tests. These are some performance numbers. Lower is better. So users A through H were the top 8 competitors. And there's a bunch of tests like loading, lookups, lookup of non-existent keys, and then delete and lookups. And these are some units of time that they're actually different across the tests. And you can see in all the cases, user H did really well. So good job, user H. Let's clap for user H. And user H is Xander Keith. Woohoo! That is either Xander Keith or someone who's a big fan of Xander Keith over here. So, are you Xander Keith? Yeah. Okay, congratulations. So, find me. Yeah, congratulations. Um, so, find me after, and we will order some O-Step swag of your choice. Like I said, I recommend things like the bath mat or shower curtain, just so you can always be thinking about operating systems. Um, or there's a nice blanket. You know, you can just sleep under the O-Step blanket. No one has literally ever bought any of those things, but they're all available. So good job. We have a project due, so hopefully you know that. Sometimes people don't. It's due tomorrow, so good luck with that. I'll stick around after if you have questions. Other than that, we'll have a new project on Thursday, and that'll have a contest component too. So we'll have a first concurrency project and a little bit of a who can build the fastest concurrent whatever, which will be released on Thursday. Okay, yeah, good job. Okay, so let's get back to this code example. Okay, so now you have to think a little bit, unfortunately. And the case you have to think about, which is harder, these are very hard to think through. You have to think through like cases, and you're trying to be, again, the malicious scheduler. You're trying to cause problems. You're trying to cause something bad to happen. So in this case, what you're going to think about is, oh, sorry, this is showing the movie recording, which we don't want. In this case, what you're going to think about is something slightly different. I'll make a little room over here. We're going to think about the case with one producer, still looking at V1, right? V1 solution. Oh, you can't see that. Sorry. You're still looking at V1, and you're looking at the case with one producer, but 2 consumers. And your job is very simple. Make something bad happen in this code, right? In this code over here, if you have one producer and 2 consumers, how can you make something bad happen? And we're trying to figure out if I should give a hint or not. Yeah. Oh, don't give an answer already. I want everybody to think about it. If you have an answer, great. Then you're going to have a fun few minutes of just thinking about other things. So just everybody think about this for like 3 minutes. If you have an answer, fantastic. But let's let everyone else think about it too. Okay, so everybody think about it and try to come to what bad thing could happen. So thank you, though. I appreciate the eagerness. Okay, why don't we just go through this together, actually? It seems like it'll be a little simpler. So let's start with, let's set up this scenario. First thing we're going to do is we're going to, and you'll ask, how do I know this? Well, I've thought about it ahead of time. So it's not like I just obviously look at this and think, oh, this is the obvious problem. Let's say consumer one runs first. What's going to happen? It'll run C1, which acquires the lock. Does it acquire it? Sure. It'll do C2. It'll check if there's anything in the queue. Because there isn't anything produced yet, it'll say, no, the numful, is 0. And so it'll go ahead and wait. So now this is blocked. And you can think of, let me erase this, make something bad happen, which is so grim. You can think of there being, remember we said the condition variable here, this is like there's a wait queue somewhere. We don't exactly know where this thing is, but we can think of there being, C1 is on this wait queue now, right? It's waiting, it's blocked. It's blocked here. Then let's say consumer 2 runs. Now remember, when consumer 1 ran, it acquired the lock, but then when it called wait, it called into wait, it went to sleep, and then it also released the lock. So the lock's still available. So consumer 2 runs, C1. It checks if there's anything in the queue, C2, and then it calls wait. Okay? We don't know exactly, and this might not even be an ordered queue, just some sort of, there's things that are waiting, right? We don't exactly necessarily know the order. Okay, then what we're going to do is we're going to run the producer. So I'm going to try to fit this all on the page here. Producer runs. It's going to acquire the lock. It is able to, because again, both of those other threads went to sleep, calling wait, which releases the lock. The producer is going to check, is there room in the queue to produce something? We didn't say how big the queue is, but let's say there is more than 0 entries. So yes, we can go ahead and find that there's something to do. We're then going to fill, right? We put some stuff in the queue, P4. And then we're going to signal, right? P5. So this is a signal. Now remember, what does signal do? Signal looks in this queue here, and it says, hey, is someone waiting on this condition? It actually sees that, yeah, C1 is, and C2, let's say it just does it in this order. So it's going to, now this is ready to run because of this signal. Okay. And then what's going to happen with P5? Let's say there's just max is 1, in fact. So this buffer that we're putting things into just has 1 entry. So we loop around again. So we'll do P6. Then we'll loop around again, P1, P2, and now it's full because we just have 1 entry. And so then we call P3, which are going to make us as a producer wait. Yeah. So when the producer waits, it means now on the wait queue, the producer's there. Okay. So consumer 1 ran, got blocked. Consumer 2 ran, it got blocked. Producer ran, put some stuff in the queue. Then it woke up consumer 1, and then it itself went to sleep, right? So then, well, what's going to happen? Consumer 1's going to run. Where is it going to run? What's the first line of code that it runs? The consumer returns from C3, right? And then it actually rechecks the condition. It says, hey, is this like this? And so it's going to do C2. Then it's going to do, and it finds that, there is something there to consume, which is great. So it does C4, which is the get itself. And then it does C5. Now this is a signal. And this is where the issue is going to happen. The signal wakes a waiting thread. There are 2 threads waiting right now. And you can see it up here, right? C2 is waiting and P is waiting. These are both waiting. When the consumer signals, which thread does it want to wake up? wants to wake up a producer, right? It said, I've consumed something, so I've made room for a producer. It doesn't want to tell a consumer that it's consumed. That's like kind of just bragging or something. Hey, I consumed something. Have you been consuming anything? No. It's a rude thread. So we don't want to do that. We want to wake the producer. Consumer wants to wake a producer. Producer wants to wake a consumer. But the problem here is the next thing on the queue, if we're just doing this kind of in a queue order, is a consumer. So at this point, if this becomes, ready, is kind of the natural thing that would happen. And then, of course, this is just going to block, and we're kind of stuck. So I mean, of course, it's hard to just look at this and figure that out. That's why people thought about this and wrote research papers about it. And then it just eventually became part of something we learned in a textbook. But you can see the interaction there is pretty sophisticated, even in this tiny, simple example with one producer and two consumers. So we're having a problem here, and the problem is the signaling is different. The producers want to wake up consumers, and consumers want to wake up producers. So that's why we try the second solution. And the second solution has two condition variables. One is called empty, and one is called, which, the producer waits on the condition empty, and the consumer signals on that. And then the consumer waits on the condition variable called fill, and the producer signals on that. But instead of using a while loop, it uses an if statement right here. So now your next challenge is and we'll just have one more challenge in class. We probably won't spend too much time on solution 4. Solution 2 is, why does the two conditions is actually correct. I'll just go ahead and give you a hint on that. But the question, which you can think about just for 2 minutes this time, is, or maybe 3 minutes, it's a little bit tricky, is why does the if cause problems? And again, I think it's easy to think about this with two consumers and one producer. So same kind of example. So just think about why does this if cause problems? Okay, why don't we talk? I've somehow killed my iPad, so we'll just have to make do. Um, if we're if we're worried, if we're trying to get the if to do the wrong thing, are we ready to come back? Okay, thanks. So if we're trying to get the if to do the wrong thing, what are we trying to do? Like what would we be trying to do if we're trying to make that so that the if is a problem? It's one way to think about this code. Like what would why are we well, like the general rule, which you can remember even if you don't remember why, is when you have condition variables and you have a state variable, you should always use while to recheck after you wake up. So always use while. So if is bad, while is good. Um, but how can we cause a problem for if? Like, how can we somehow make it so that that's somehow bad? That's the way to think about this problem here. Does anyone have some insight into that or thought about that? At 6:40. It's very tough to do at this hour. Okay, so let's just do it together. That's fine. Let me make a little window here, and I will switch, and I'll do this, and we'll kind of, right, let me make this a little bit bigger, and let's just do, let's make a little Emacs buffer here. So Emacs is life, as we all know. Emacs is everything. Package CL is deprecated. That's terrible news. Okay, so we have one producer, we have two consumers, and we want to cause problems for V2 of the solution. So let's imagine this case where consumer runs first. So consumer one first. What's going to happen? It does C1. Let's just kind of work through this. C1, C2, C3, because there's nothing there. And again, let's just assume one consumer max equals one. And then it waits. So now we have it waiting, right? No problem. Let's run producer over here. Now the producer is going to do just the standard thing too. It's going to produce stuff. That's what producers do. So it's going to run P1. Then it's going to check if it's full. It's not. So then it's going to go to 4. It's going to fill the buffer, which is great. So now num full equals 1. Then what it'll do is, it'll signal, right? Sorry, I don't need to check on that. P5 signal. And at that point, what do we know about this consumer? Now it's, oh, sorry. Now it's ready to run. That's my problem. It wants to do that. So this is ready to run again, right? So consumer one is now runnable. It could run. Doesn't mean it runs. It just means it could run. And then, we do P6 and let's say, we're done. We can kind of loop back through and wait, but it's no big deal either way. So now we have a situation where there's a consumer. You can see this is already kind of setting up the problem. There's a consumer that's sitting there and it thinks it's ready to consume something, but it doesn't yet necessarily have the ability to do that consumption. It's just been woken up, hasn't yet reacquired that lock that's now free, and therefore it hasn't returned from that, hasn't returned from wait. So what could happen between that moment where the consumer one is woken and before it actually can do any work? Is what can happen is our old buddy consumer two over here can decide it wants to run. So consumer two absolutely can run at this point, no problem. It does C1, it grabs a lock. The lock has not been, transferred to consumer one. The producer just released it. Consumer one hasn't run yet, hasn't been able to reacquire it. Consumer two then says, oh, consumer two says, I'm going to run line C2. Is this full? It's actually not. It does C4, so it does the get. It then does, C5, signal, no problem. C6, no problem. And then let's say at this point, consumer one gets to run again. Consumer one getting to run again means it's going to acquire the lock and return from wait. And it's not going to check, is there anything there to get? And that's the problem here. This runs, but this is a bug. And the bug is that it tries to consume from an empty queue. And the way that our bounded buffer is implemented, it would actually just get some old garbage value. Now, you can imagine checking, is there anything actually in the queue, and then failing in some way or skipping it, but we can do better than that. But this is the heart of the problem. So the actual solution, which you just need to study to understand, and we'll do some little tiny quiz around it at some point. I mean, homework and eventually a test. I'm sure we'll 100% talk about this producer consumer problem, is having two condition variables and then always rechecking with while the condition that you're waiting on. So two condition variables, so producers only wait consumers, consumers only wait producers, and then this condition, this while loop to make sure that when you get woken, that you make sure that the state of the world is actually what it was, what you think it should be. You can see in this trace here that we looked at, the time you got awoken was a lot different from the time you actually ran. There's no guarantee that you run right away. And because of that, you have to recheck the state of the world. So that's an introduction to producer consumer problem. I'll stick around if people have questions about other stuff. Otherwise, we'll see you next time. Thank you.